this says a circuit is connected as shown in the figure with the switch open. When the switch is closed, the total charge that flows from Y to X is. This is very crucial. I keep telling students again and again. Most students will go till here and they will think that they've made a mistake. So this is a regular Doppler effect question, which means the source and observer coming towards each other. So this is a theoretical question. We know diamagnets have the least susceptibility because they have a small negative value, but that is not your answer. Be very careful, be very mindful of that. Here we're moving from one point to the other. We want to see what the speed is going to be. We have to equate change in potential energy to the kinetic energy. This VL and VC are equal. And we know by phasor diagram, VL and VC are in opposite directions. 95 percentile versus a 99 or 100 percentile are questions like this. Hi students, welcome to this session here. I'm Aniruddha, your physics faculty at Infinity Learn by Sri Chaitanya. And today we are starting off the series where to prep you up for your JEE Mains that is coming up very soon, we're going to have a series of mock tests where we'll discuss questions. We'll have many questions, good competitive level questions where we'll look at how to solve them so that you stay in practice. Now, most of these tests are going to be full syllabus tests. So we'll cover questions from all of them, and there might be one or two PYPs as well. But if you're in your preparations this far ahead, I'm hoping you've done most of your PYPs. So there's even going to be other types of questions, not just the generic PYPs, but many types of questions. We'll look at all of them, solve them in detail, and throughout the process, I'll also be giving out tips and tricks with regards to how you can solve those questions quicker. So stay with me throughout this session, and if you want to stay throughout the series for all the coming videos, subscribe to Infinity Learn by Sri Chaitanya. That said, let's get started with the session now. The first question that I have says that a block of mass m1 rests on a horizontal table. A light string connected to it passes over a frictionless pulley at the edge of the table, and from its other end, another block of mass m2 is suspended. The coefficient of kinetic friction between the block and the table is mu k. When the block A is sliding on the table, you need the tension in the string. So first up, draw out what it looks like. Now, if you're in your competitive, you might not have to draw if you have that much practice. But because we're explaining things here, this is our first block, which we are calling as M1. And you have through the pulley, the other block, M2 over here. This block M2 moves down with an acceleration A, which means this moves in this direction with an acceleration A. Tension in the string is T, and you have the frictional force over here, which, as you can tell, if the acceleration is in that direction, the frictional force is going to be in this direction with mu k m1 g. That's going to be the frictional force magnitude. Coefficient of kinetic friction multiplied with the normal reaction force. Now over here, I want you to remember the relation for the acceleration. A was equal to the competing forces divided by the sum of the masses. So what are the competing forces? Forget tension. What are the competing forces? You have m2g downwards. So it's essentially m2g. We'll keep the g as a common later on. m2g competing with mu k m1g. Those are the only two forces you need. So you have m2 minus mu k m1 into g divided by, these are the competing forces. I put negative sign because they were pulling in opposite directions, divided by the total sum of the masses, that is m1 and m2. So it makes it m1 plus m2. Now this is the acceleration. Remember this relation. This is easy to get to once you know the competing forces. From here, think about the free body of any one of them. We'll take the free body of m2 because it's easier to deal with. So for the free body of m2, I have m2g minus t is equal to m2a. Now I need to find this t over here. The a we already have. So if I do it, t becomes equal to m2g minus m2a. Now a is this. So let's do that. I have m2 minus mu k m1g divided by m1 plus m2. Now over here we can open it up. We can open it up and see what we get. Let's pull this on this side. We'll be having t is equal to M2, we'll take the entire G common. So let's take the G out first. Then you have M1, M2 plus M2 square. M1, M2 plus M2 square. And over here you'll be having minus M2 square plus minus M2 square plus mu k M1, M2. Right? When I've opened this up, and the entire thing would be divided by M1 plus M2. Now over here we see the M2 squares are cancelled out, everything else stays as is. Take M1, M2, so you have M1, M2 plus mu k M1, M2. Take M1, M2 out, you have essentially this relation over here. M1, M2 into 1 plus mu k stays in into G divided by M1 plus M2. So that is our correct option. Let's look at the next question. This says the relation between the energy U, pressure P and volume V for an ideal gas in an adiabatic process is given by the relation U is equal to A plus BPV. Find the value of the adiabatic exponent gamma of this gas. So the way we'll do here is that in an adiabatic process, we know that dQ is 0. So by first law of thermodynamics, we know that du should be equal to minus dW. And also for the adiabatic process, we know the formula for our work done. Okay, so we put that in. du is equal to nR divided by gamma minus 1 into dt. It is T2 minus T1. We'll keep it dt. Okay, the negative sign goes away because originally it was 1 minus gamma. So over here, if I now integrate both sides, then on this side I will get u as expected. On this side, I will get nRT divided by gamma minus 1, and be very mindful because I've done an indefinite integration here. There is also the constant of integration C. Fine? I've just integrated from here. Why? Because I need a way to introduce this gamma in my equation. I need a relation between u and gamma, because when I have that, then I can get it because I have a relation for u here. So that was my goal to proceed down this path. Now I need this constant of integration. Now if you look with regards to this setup over here, then you know that it's essentially an ideal gas, which means over here you can have, if you put T is equal to 0, at T equal to 0, we know PV is equal to 0 because PV is equal to nRT. PV is equal to nRT. So when T is equal to 0, PV is 0. So at T equal to 0, PV is equal to, PV is equal to 0. And if you put PV equal to 0 here, you see that at T equal to 0, you also have U is equal to 0. Sorry, my bad, U is equal to A. U is equal to A. I'm making tiny mistakes here. Never mind. So U is equal to A over here. So that means at T equal to 0, U is A. If you do the same thing, at T equal to 0, U is A, you will get that this constant of integration is actually equal to A. This A, this exact A over here. Now look at this relation where you can replace this nRT with PV. You would be having PV by gamma minus 1 plus A. Now compare this equation that we got and derived with the equation given over here. If you do that, you will see you have this A plus a constant into PV, which is going to give you, which will give you that B is equal to 1 by gamma minus 1, which if you just shift terms around, you will see that you'll get gamma minus 1 equal to 1 by B. So gamma equal to 1 by B plus 1. So gamma will be equal to 1 plus B by B. So do we have an option? We have an option here, B plus 1 by B. So that is how you get to. Now this I would say is one of, it's a bit more difficult, it's a bit trickier, because getting down this path is the real challenge, and also knowing you could also go out in here, then put the value of U here and make the process longer. But because we have done it with the constant of integration, we have been able to compare, and comparisons are always the faster way to get to solve questions, especially the ones where you can compare the coefficients. Okay, that's it. Let's move on to the next one. This says that a diode detector is used to detect an amplitude modulated wave of 60% modulation by using a condenser of capacity 250 picofarad in parallel with a load resistance of 100 kilo ohm. We need the maximum modulated frequency which could be detected by it. Now over here, why would this capacitor and this resistor create a problem? Because they have that time constant, which means it takes time for the signal to die down, it takes time for the current to rise up. So if your frequency that's coming in that is greater than or less than that or comparable to that, then you would get thrown off. You can't measure that because did you get a peak or is it still going down slowly? You won't be able to detect it. So there's a direct formula for that in case you do not know, based on the modulation given over here and this time factor. We have the frequency f is equal to 1 by 2 pi into m, which is this modulation over here, into the time constant tau. We know for this RC circuit, time constant is R into C. So RC. So if you don't know this formula for this kind of question, there is the formula for you. You can use it multiple times. So again over here, let's put in the values. We have 2 pi into m is given as 0.6 multiplied with R is 100 kilo ohm. So 100 into 10 to the power 3 multiplied with C, where C 250 picofarad. So 250 into 10 to the power minus 12 farad. So over here you need to calculate. Now see the values given over here, we'll try to approximate it somewhat. We'll try to somewhat approximate it. See, if I have this down here, 2 pi I'm approximating is 6. Okay, it goes to 6.28, but I'm approximating it to be 6. Let's keep the approximation sign. 6 multiplied with 0.6 multiplied with 250. 250 into, you have the rest of them are all 10 to the power something. So you have 10 to the power 2 into 10 to the power 3, 10 to the power 5 multiplied with 10 to the power minus 12. Gives you 10 to the power minus 7. Right? Okay, so we have got it. We have got it 6 into 0.6. That's going to be roughly 36. 3.6 into 25. So I can treat this 3.6 to be roughly equal to 4. Why do I take it to be 4? Because then 4 into 250 could take me to a factor of 10. See, I'm doing minute approximations here, and the reason I can do that is because all of my options are pretty far apart. You would say this 10.6 to 10.61 are close by, but this is megahertz, this is kilohertz. And then you have this big difference between 10 and 5, even when you're dealing with kilohertz. So over here, it's 0.36, it should be greater than 3.6 because this was 6.28, I took it as 6. So if I treat this as 4 and this as 250, then I will get it as, again, approximation. 1 by 4 into 250 is 1000, 10 to the power 3, which makes it 1 divided by 10 to the power 3 into 10 to the power minus 7 makes it 10 to the power minus 4. Which means I could write this as approximately 10 into 10 to the power 3. So it should be 10.61 kilohertz. I'm getting roughly close to 10. And I'm also getting a 10 to the power 3, which means it goes in the kilo approximation. It goes in the kilohertz, not the megahertz. For megahertz, I would have needed 10 to the power 6. Anyway, that approximation takes us over here. This is very, very crucial. I keep telling students again and again. Most students will go till here and they will think that they've made a mistake. Because how do you calculate this? Even if you start calculating, it's going to take a long time. Multiplication is still simple. You would have to divide again. So students panic a lot. So at this point, I tell you, generally, if in JEE they give calculations like this, they'll also keep the options spaced apart so that you can use your approximation to arrive at an answer that is close to one of them, and then you can figure out which one it is. Okay, so let's move on to the next one. This says in a double slit experiment, two slits are 1 millimeter apart and the screen is placed 1 meter away. A monochromatic light wavelength nanometer is used. What will be the width of each slit for obtaining 10 maxima of double slit within the central maxima of the single slit pattern? So when I'm dealing with the single slit pattern, that is diffraction, and the two slit is interference. Now in diffraction, I know what is the width of that central maxima, width of the first part of this diffraction. Why? Because I know that the first dark band is formed in diffraction pattern at x, let's call it diffraction xd, is equal to lambda capital D by small a. Lambda capital D by small a. Okay, that is where the first layer, first dark fringe forms in diffraction. If you want, this distance is from the central point. This is xm, right? This is this xd. So one dark band formed here, the other dark band would be formed a same distance xd away from the central point. So what is the width of that central maximum? The width of the central maximum is 2xd. So you will have actually what we need with regards to this, let's call that capital L. That width is equal to 2 lambda capital D divided by A. That is the entire width. Now you want 10 maxima of the double slit interference pattern to fall over there. Now that means you have fringe widths. In interference pattern, you have fringe widths where each fringe width beta is equal to lambda capital D by small d. Now mind you, this A refers to thickness of one slit. This small d refers to the distance between two slits. Okay, that is provided over here as two slits 1 millimeter apart. Now I've been told that 10 of these fall within this space, which means L would be equal to 10 lambda capital D by small d. That is the distance required for 10 of these fringes, which means this is equal to this. If you do that, you can obviously cancel out the lambda d's on both sides, leaving your A is equal to 2d divided by 10. Now d is given to you already as where is it? It's 1 millimeter. See, this lambda and everything 1 meter away, you don't need it, they cancel out. So you have 1 millimeter, put that in, you have 1 by 10, 0.1 into 2, that is 0.2 millimeter over here. Okay, let's move on now. Next question. This says a circuit is connected as shown in the figure with the switch open. When the switch is closed, the total charge that flows from Y to X is. Now only think of the steady state cases over here. When you have this open, when the switch is open, then essentially you have these two capacitors in series, which means their equivalent is going to be 3 into 6 divided by 3 plus 6, 3 into 6, 18 by 9, that is 2 microfarad. The equivalent is going to be 2 microfarad. Now the potential difference is going to be this 9 volt over here, which means the charge that is in this piece is given by, let's put it this side, okay, let's do it on this side itself. Q1 is equal to C equivalent into V, which is equal to 2 into 9, that is 18 microfarad, 18 microcoulomb, my bad, 18 microcoulomb. Now in this 18 microcoulomb, it's the same charge in both of them because they are in series. Remember, this middle part is not there, so they are in series so far. And because the charge is same, you know there's 18 microcoulomb on this, 18 microcoulomb on this, with this side being positive, this negative, positive and negative, which means I can assume this plus 18 microcoulomb here, minus 18 microcoulomb on this plate. Similarly, plus 18 microcoulomb here, minus 18 over here. Because there's minus 18 over here and plus 18 here, you know the charge at this point is 0. Because essentially the charge has got redistributed. The total charge over there is 0. Okay. So we'll keep it Qx is equal to 0. In the second case, as soon as you connect both of them, now the potentials and everything change. Why? Because as soon as you connect them, you can think of this circuit as looking like this. You have this 3 microfarad here, you have the resistor here, and this is a separate piece. Over there, this is your 3 ohms, This is your 6 ohms. And over here you have 3 microfarad and here you have 6 microfarad, right? Which means now the potential difference across these 2 points is going to be 3 volts and over here it is going to be 6 volts. How do I know that? Because in series it's 3 plus 6, 9. 9 ohms. You have 9 ohms divided by 9 volt, that is 1 ampere. 1 ampere through this is 3 volts, through this is 6 volts. Okay, that's how the voltage is distributed. So now it's 3 volts. So how much charge is there in this? The charge in this is now 9 microcoulomb because V into C over here. And in this case also the potential into this means the charge here is 6 into 6, that is 36 microcoulomb. Now what does that tell you? As soon as you connect this, you have minus 9 here and plus 36 here. So what is now the charge at X? The charge is 36 minus 9. So let's call it QX1. QX2 with the S connected is now 36 minus 9, that is 27 microcoulomb. Which means in order for it to go to this state, the charge has to flow into X. Originally X needed 0 charge, no problem there. But as soon as you connect, the charge at X has to be 27 microcoulomb to maintain everything. That means charge flows from Y to X and that value is here 27 microcoulomb. Okay? I know this is again can be a bit difficult, but I am telling you it's questions like these that define what your rank is, especially if you're targeting top marks. What separates a 95 percentile versus a 99 or a 100 percentile are questions like this. Okay, so we'll be doing more questions. Keep with us throughout the session and you'll get to know about that. This one says from the top of a tower, a particle is projected with a velocity of 19.6 meters per second at an angle of 30 degree with the horizontal. If g is equal to 9.8 meters per second square, the particle will move at right angles to its initial direction of motion after a time. So over here, this suppose is the projectile motion. You launched it and it's coming down, and this is the point where if you look at the direction of velocity, this is your launch velocity, right? If you trace it out and if you trace this back, then this is 90 degree. If you take that to be 90 degree, then let's approximate what the other angles are going to be. If I create a straight line over here, if this angle was theta, the launch angle, then this angle is also going to be theta. Okay? Now there's shortcuts to this, but I want to break this down and show you so that you understand how to deal, because this is a common question. There could be variations to this. There's a shortcut where it will only apply to this question, but that will not go into. Once you get down the main process, you'll understand that shortcut as well. Anyway, so over here, think this velocity, it's here at V, here it is U. This velocity can have two components. One is this one, Vy, and in this direction you have Vx. Now Vx has to be the same as Ux, because we know in our motion over here, in our projectile motion, horizontal speed never changes, which means U cos theta is equal to V sin theta, because Vx is V sin theta, equal to V sin theta, which means V is equal to U cot theta. Now what is U given to us? U is given as 19.6. Okay, we'll put in the values a little later. So we have got V. Now next thing we need is what is the velocity in the downward direction. Why is that important? Because based on that we'll be able to find the time. Now this velocity, suppose from the peak point, the vertical velocity was 0. At this peak point, vertical velocity is 0. So from that point, how long does it take to achieve the velocity Vy? Remember, Vy is V sin theta, V cos theta, right? Let's do that. We use V is equal to U plus AT relation, where V cos theta is equal to gt, because the initial velocity is 0 at the top point. So what do we get here? Let's put it. We have u into cot theta into cos theta. Cot theta cos theta is equal to gt. So t is equal to, what is u? U is 19.6. 19.6 multiplied with cot theta, the angle theta is 30 degree. So cot 30 degree is going to be root 3. Root 3 into, you have cos of 30 degree, which is root 3 by 2. By 2. So here you have root 3 into 3 gives you 3. Okay, we have a g below. So g is 9.8, which means this goes with 2, this 2 goes here. So you have t is equal to 3. But that is not your answer. Be very careful, be very mindful of that. Why? Because that is the time from here to here. How long does it take to go from this point to this point? And that is given by u sine theta by g. T up is equal to u sine theta by g. So if you do that, you get u value is 19.6 into sine theta is sine of 30 is half, divided by, you have g, that is 9.8. So they all cancel out, you get it as 1. So 1 second is the time taken to go here, and from here to down here is 3 seconds. So that means the total time is 4 seconds over here. That is our correct answer. Okay. The next question says that two cars moving in opposite directions approach each other with a speed 22 meters per second and 16.5 meters per second respectively. Driver of the first car blows a horn, frequency 400 Hz. Frequency heard by the driver of the second car is. So this is a regular Doppler effect question, which means you have source and observer coming towards each other. So your apparent frequency f dash is equal to V plus VO divided by V minus Vs into f, the original frequency. So V plus VO, what is VO? Speed is 16. The other one is 16. The observer is 16. So it is 400, right, is the speed. Oh, the speed of sound is 340. The speed of sound is 340. The frequency was 400. So it's 340 plus 16.5 divided by 340 minus what is Vs, that is 22. 22, and you have into 400 over here. So what does that give us? That gives us 340 into 16.5 is 356.5. 356.5 divided by 340 minus 22 is 318 multiplied with 400. So you can tell that it will be greater than 400. It will be greater. Now over here again you can calculate and try to solve it, but even with regards to this you can just use an approximation that it will either be 411 or 448. But this will come with practice to you. That is why I tell you, you need more and more practice. That over here if you calculate, you will see this difference, this factor that you get is 2 less. This factor is, my bad, it's not 2 less, it's actually, it can't take you to 411. Right off the bat, you can see that that fraction is considerably bigger than 1. For 411, if you had 400, and even if this factor was just 10%, right, then you would have gone to 440 just by that. Okay, if this 318, 10% of 318 is what? It is 31, 32. Let's take it 32. Even if you add 32 on top of it, okay, you get to 350. Right? It's even more than 10%. And a 10% increase in 400 would have taken you to 440. So if it is more than 10%, you know the only possible option is 448. That is how you approximate. Okay, is there a 10%? See the 10% thing or not? It's greater than 10%. The gain over here is more than 10% of this. So the final answer should be more than 10% of this. Okay. The next question says that a moving body with a mass m1 and velocity u strikes a stationary body of mass m2. The masses m1 and m2 should be in the ratio of m1 by m2 so as to decrease the velocity of the first body to 2u by 3 and giving a velocity of v to m2, assuming a perfectly elastic impact. The ratio of m1 and m2 is what we need to find. Now, because this is a collision question, right off the bat, we know we have to use the conservation of momentum. So, what is the initial momentum? We have mass m1 moving with a velocity u. So, we have m1u and that's it, because the second body m2 is at rest. This is the entire initial momentum. And that is equal to the final momentum where m1 is moving with a velocity 2u by 3. Since it's decreasing velocity means it's moving in the same direction. So, this one is going to be m1 into 2u by 3 plus you have m2 moving with a velocity v given over there, m2v. Now, if you just shift this over to this side, you will get m1u minus m1 2u by 3. So, taking m1u common, you have 1 minus 2 by 3, that is 1 by 3. That will effectively give you m2v is equal to m1u by 3. Now, from here we can't get m1 by m2. That is because over here we have v and u. And the final answer we want in actual numbers. We don't want any variables over there. So, the second thing that's going to help us is the coefficient of restitution. We know the coefficient of restitution E is equal to relative velocity before approach divided by relative velocity after approach. So, before approach, relative velocity is u because second body is at rest, the first body moving towards it with a velocity u. After the collision, the second body moving with a velocity v and the first body chasing behind it with a velocity 2u by 3. So, the relative velocity is v minus 2u by 3 because v and 2u by 3 are in the same direction. Now, it's a perfectly elastic impact, which means E, the coefficient of restitution, is 1. If you put 1 here, you will get v minus 2u by 3 is equal to u. So, your v will be equal to 5u by 3. Let's put that in here. If you do that, you will get m2 into 5u by 3 is equal to m1 u by 3. Cancel out u by 3 from both sides. You have m1 by m2 is equal to 5. So, correct option is option A. Okay, let's move on to the next one. This says susceptibility of dia, para, ferromagnetic materials are chi D, chi P and chi F. Then what is the ratio, how strong they are, the increasing or decreasing order. So, this is a theoretical question. We know diamagnets have the least susceptibility because they have a small negative value. Paramagnets are more than that, they have a small positive value, and ferromagnets have a very high value, very high positive value of susceptibility. So, this is a theory based questions. This is our first option. All of these are chi, by the way. Gammas have come as a misprint. Next question, a hollow cylinder has a charge q coulomb within it if phi is the electric flux in units of volt per meter, in units of voltmeter associated with the curved surface B, the flux linked with the plane surface A in units of voltmeter will be. So, over here we assume that the charge q is symmetrically at the center, which means at that point the entire flux coming out of this entire flux or the entire field lines coming out of this q is going in these three surfaces A, B and C. So, the total flux is phi A plus phi B plus phi C. And the total flux by Gauss law is equal to q by epsilon naught, enclosed charge by epsilon naught. So, we have q by epsilon naught over here. Now, phi B, the flux through B is already provided as phi. And because it's symmetrical, the flux through A and C are going to be the same. So, we have phi A is equal to, even if it's not symmetrical, it doesn't matter, even if you have it skewed on any side, still the flux would be the same. Still the flux could be the same. So, over here we have phi A equal to phi C, that is, so I can treat them both as phi A. So, my equation now reduces to 2 phi A plus phi is equal to q by epsilon naught. This phi B becomes phi C becomes phi A. So, phi A is just equal to half of q by epsilon naught minus phi. We have an option here, yes, that is our correct option. Next up, It says a mass m attached to a horizontal spring executes SHM with an amplitude A1. When the mass m passes through its mean position, then a smaller mass small m is placed over it and both of them move together with A2. Now, at the mean position, this is all happening. So, at the mean position, we'll consider it like a collision. In that collision, it's an inelastic collision because the small m and capital M, after you place, they move together. So, we'll treat it as a completely inelastic collision. So, what is the velocity, what is the momentum originally? Momentum is m into v1. And that initial momentum is equal to the final, the second body is just placed. So, second body has no velocity. So, the final momentum is capital M plus small m into v2, because now the entire mass is capital M plus small m and the velocity is v2. Now, mind you, these velocities, these would become two separate SHMs because the mass is different, amplitude would change. That is what we have been asked to find here. But because it's happening at that mean point, you know the velocity is going to be the maximum velocity for the SHM. And the maximum velocities relation is V max is equal to A omega. And omega is equal to root over k by m. So, it is A root over k by m. Which means in this case, for the first case, you have m into A1 into root over of k divided by m, because then the mass was just m, amplitude was A1. In the second case, you would have capital M plus small m into V2. V2 is A2 into root over of k divided by capital M plus small m. Okay, because that is the mass now. From here, we need the A1 by A2, right? So, if I do, firstly cancel out this to make this root m, cancel this out to make this again root m. These root k's cancel out. So, you have A1 by A2. A1 by A2 is equal to capital M plus small m divided by capital M to the power half, root over of the entire thing. So, correct option is option C. Okay, let's move on. This one says point P lies on the axis of a ring of mass capital M, radius capital R, at a distance capital R from its center C. A small particle starts from P and reaches C under gravitational attraction only. Its speed at the center C will be. So, since here we are moving from one point to the other, we want to see what the speed is going to be. We have to equate change in potential energy to the kinetic energy. What is the potential energy at this point? The distance is R root 2. So, because it's a uniformly distributed mass over here, and since we're finding potential, we can just add them up. We don't need to worry about vectors, sign, cos components. So, that means the potential, let the mass be small m, then the potential energy at this point is Gmm divided by R root 2. And when you bring it to the center, then the distance becomes just R. That is the only change. Just the distance is changing. So, the difference in potential energy is this minus Gmm divided by R. Right? Now, this is actually just the opposite. It's plus and this is minus because potential energy is generally given with the negative sign. So, we'll have this minus, this will be plus, and then that is equal to your half mv square. Cancel out these m's from both sides. You have v is equal to root over of 2gm by r into 1 minus 1 by root 2. Right? If you just shift them, take things common, you'll get it. We have an option for that, that is option B. Okay. Next up, it says the figure shows a thin metallic rod whose one end is pivoted at point O. Rod rotates about the end O in a plane perpendicular to uniform magnetic field omega in clockwise direction. So, clockwise direction means it's turning in this direction. Now, over here, if it is turning in that direction, we have to check in which place the free electrons move, in which direction do the free electrons move. So, forget about motional EMF and everything. Just think with respect to motion of electrons. If this rod is moving in this direction, the velocity is in this direction, v. If it's positive charge, we know it's Q V cross B. So V in that direction, cross B, curl fingers into the page, V cross B. So thumb points up, but that is the direction of the positive charges. Since electrons are negative charges, they will move in the opposite direction. So electrons will move towards this point over here. So the free electrons of the rod move towards the pivoted end. Okay, just use your right hand thumb rule here. Next one, it says for a prism kept in air, it is found that for an angle of incidence, the angle of prism A, angle of deviation delta, and angle of emergence E become equal, then the refractive index of the material of the prism is. So over here, we can use the relation that your angle of deviation delta is equal to I plus E minus A. Now over here, the angle of emergence is equal to the angle of the prism A, which means this E and A would be equal, they would cancel out. So your delta is just equal to I, which is given as 60 degree. So delta is 60 degree, right? We also know that delta is equal to R1 plus R2. Now over here you see, since delta is 60 degree, your angle of emergence is also 60 degree because angle of prism, angle of deviation and angle of emergence are same. So angle, there's a simpler way also, I'll show you that as well, but this is the trickier way to go about it. So the angle of emergence is equal to the angle of incidence. When does that happen? That only happens when you have the delta is at its minimum deviation. You have the minimum deviation case, and in minimum deviation case, delta min is equal to 2R, or R is equal to delta min by 2. Delta min we got is 60 degrees, so R is equal to 30 degree. From there you can directly get the refractive index. N is equal to sin I by sin R, and that would give you equal to sine of 60 is root 3 by 2 divided by sine of 30 is half, so 2 would come up top, cancel them, you have N is equal to root 3, that is 1.73. You could, instead of going this way, you could also do N is equal, you can also use the relation of N is equal to sine of A plus delta M by 2 divided by sine of A plus 2. You can even go by this method, but I just showed you both ways as well. Next one says a circular hole of diameter R is cut from a disc of mass M, radius capital R. Circumference of the cut passes through the center of the disc. The moment of inertia of the remaining portion of the disc about an axis perpendicular to the disc and passing through the center is. So there's quite a few steps to this. Stay with me throughout. Over here, originally we have, this is the original disc, this is the central point. It is said that I'm cutting out this piece over here. Now let's assume that the disc, this piece, the remainder of the piece, we are cutting this part out. Let's assume that the remainder piece has the moment of inertia given by IA, and this piece has the moment of inertia about this point given by IB, right? And you have the entire moment of inertia. So IA plus IB is equal to mr square divided by 2, which is the moment of inertia of the complete disc about its center. Now IA is what we need to find, but before I can get IA, I need IB, which is the moment of inertia of this piece about an axis over here. First up, I need what is the mass of just this piece. To get the mass of that piece, let's do those steps here. To get the mass, I know the total mass is capital M, the radius is capital R. So just by unitary method, I know that the mass of that piece, MB, is equal to M divided by pi R square into pi of R by 2 square. Because M by pi R square is the surface mass density multiplied with the area of just this piece. If you do that, you will get MB is equal to M by 4. So we've got MB. Now what is IB? Before I can get IB, I need IB dash, which is the moment of inertia of this piece about its own center. Okay, so IB dash is equal to m by 4 into r by 2 whole square. M by 4 into r by 2, because it's just mr square. There will be a 2 factor also here, because formula is half mr square. So half into m by 4 into r by 2 whole square. So that makes it mr square divided by, you have 4 into 4, 16 into 2, mr square by 32. This is the moment of inertia of this piece about its own center. I need the moment of inertia of this piece about this point over here. So I'll use the parallel axis theorem. According to that, IB is equal to IB dash plus m by 4, which is the mass of this piece, into r by 2 whole square, which is how much you are shifting it by. So that gives us mr square by 32 plus mr square by 16. That is equal to 3 mr square by 32. That is the moment of inertia of this removed piece about the center of the entire disk. Okay. Now we put it in, so we get IA is equal to mr square by 2 minus 3 mr square by 32. That makes it 16 minus 3, that is 13 mr square divided by 32. So do we have an option? This is our correct option. There's many steps to this, but remember the steps, because this is quite a common question. You'll expect this kind of question, this one piece removed, sometimes it's a circle, sometimes it's a square. So the key here is you have to just assume the other piece was originally added up to the removed piece. But you have to take care that whenever you're adding moment of inertia or subtracting moment of inertia, all of those moment of inertia should be about the same axis. We got the moment of inertia about the central axis, we had to shift it by parallel axis, then we could use this. Let's look at the next question. It says a gaseous mixture consists of 16 gram of helium, 16 gram of oxygen. The ratio of Cp by Cv is. So first up, what does 16 gram of helium mean? Helium has a molar mass of 4 grams. That means 16 gram means there are N1 is equal to 4 moles of helium. And oxygen has a molar mass of 32 gram. So 16 gram of oxygen means the number of moles of oxygen is half. This is half mole of oxygen. Over here, I now need to find Cp and Cv separately. And the relations are pretty straightforward, because Cv, the net Cv of this combination, is N1Cv1 plus N2Cv2 divided by N1 plus N2. Now N1 is 4, multiplied with Cv1, which is Cv for helium, which is a monoatomic gas. So it's going to be 3 by 2R, plus N2 is half, multiplied with Cv2, which is the Cv for the diatomic gas, which is 5 by 2R, divided by, here you have N1 plus N2, that is 4 plus half, that is effectively 9 by 2. So let's see what we can do. We can remove the denominator 2 from each case, one denominator 2. So here you have 12, multiply this here, so you have 12 into 2, 24 plus 5, 29 divided by 18. So you'll have 29R divided by 18 here. What about Cp? Cp is equal to N1Cp1 plus N2Cp2 divided by N1 plus N2. And that again we can put in the values. N1 is 4, Cp1 is Cp for a monoatomic gas, that is 5 by 2R, plus N2 is half, multiplied with Cp for a diatomic gas, that is 7 by 2R, divided by, you have N1 plus N2, that is 4 plus half, that is 9 by 2. Again, what can we do? We can remove the one denominator 2 from each case. You have 20 here, cross multiplier 2 makes it 40, 40 plus 7, 47 divided by 2 into 9, 18. So 47 R by 18. Now I need CP by CV. CP by CV is just this. Again, the 18s will cancel out, the R's will cancel out. You'll effectively just be having 47 by 29. Nothing can be done about this. Nothing will cancel. They're both prime numbers. Only thing to proceed with over here is to go with normal division. So let's do this. It won't be too difficult. I'm hoping it won't be too difficult. You have 47 here, 29 here. Of course, it will go with 1. You put 29 down below. 8, 3, 1. 18 makes it, put a point in here, makes it 180. So 180, I know 30 into 6 is 180. So 29 into 6 will be a little less than 180. It would be 174 because it should be 6 less than 180. Okay. So if I put 6, I get 174 here, right? And we don't need to move any further. Once I've got 1.6, I know something else is going to come after that. So there's only one option with 1.6, that is this. So we can mark right away. So even though it looks like we have a long division to do, long division is so simple, beyond 2 steps, you don't even need to consider. Moving on to the next one. So over here we have this logic gate system. Like we have to find what the truth table for it is. Let's do it. We have A and B coming into this NAND gate, which means here the output coming out is A dot B bar. This A dot B bar is fed into this NAND gate with an A here, which means over here we have A dot B bar, and the entire thing is made with a bar on top. Similarly, similar thing comes here, but this time it's patterning with the B. So we have B dot A dot B bar, and over here because it's a NAND gate, so A dot B bar one input, B is the other input. We get, again you feed it out, so your Y becomes equal to this is fed in, this is fed in, so A dot B bar and bar up top dot B dot A dot B bar with a bar on top divided by with a complete bar to make a NAND over here. So let's simplify again. De Morgan's theorems will really help us out here, because by De Morgan's, if you have the bar over 2 multiplications, it's split up as individual pieces with the OR sign. So you'll effectively be having A dot B bar plus B dot A dot B bar. Why? Because these two would separate in an OR function with a not on each. So not of not will cancel out the knots, make it positive. Next, what can we do? We can even spread this up, I'm assuming, because if I spread it up, I got A dot A bar plus B bar plus B dot A bar plus B bar, right? That gives me over here A B bar plus B A bar. That is the truth table of a exclusive OR gate, XOR gate. We know that is the notation. That's the Boolean relation for an exclusive OR gate, where you have 0 when the both of them are same. You have 1 where both of them are different. So that is this one. This is the one where you see when both are same, it is 0. Both are same, it is 0. When both are not same, you have 1. Okay, that's exactly what is going to happen here. If you have 0 and 0, then all of them are going to cancel out. Only if you have 0 and 1, then in one place, one of them, you are going to have 1 into 1. That's going to give you a 1. Moving on, this says the angles are required to be measured using an instrument. 29 divisions of main scale exactly coincide with 30 divisions of the vernier scale. If the smallest division of the main scale is 0.5 degree or 30 minutes, then the least count of the measurement is simple formula based. We know that the least count LC is equal to 1 MSD minus 1 vernier scale division. So 1 main scale division is, where is it? Half minute. So 30 minute minus 1 vernier scale division is because 29 match with 30 over there. So we have 29 by 30 into 30 minutes. Since 130 main scale 30 pieces over there correspond to the 30-minute part. So over there that makes it 30 minutes into 1 minus 29 by 30, that is equal to 30 minute into 1 by 30, that makes it 1 minute. So the answer is 1 minute. The least count is 1 minute. Okay. Next one, two radioactive nuclei P and Q in a given sample decay into a stable nucleus R at a time t equal to 0. Number of P species are 4 and 0 and that of Q is n 0. Half-life of P is 1 minute whereas that of Q is 2 minutes. Initially, there are no nuclei of R present in the sample. Then the number of nuclei of P and Q are equal. The number of nuclei of R present in the sample would be a long question, but again, simple relations. We know n by n naught. In the first case, n by 4 n naught would be equal to half into t by t half. So t by it's 1 minute for the first case, right? And on the other case, on the second one, you have n by n naught is equal to half into t by 2 minutes because then the half-life was 2. Over here, I can get n is equal to 4 n naught divided by 2t, and here I have n is equal to n naught divided by 2t by 2. Now let's equate them, because if you equate them you can get that time out. If you equate, you get 4 n naught by 2t, 2 to the power t is equal to n naught by 2 to the power t by 2. Cancel out these n naughts. We have 4 is equal to 2 to the power t into 1 minus half. That if you see, you will get t to the t into half. So t into half is equal to 2 to the power 2. So t value will come as, t would be equal to 4 minutes, right? We have got the t value as 4 minutes, but that is not it. I need to find the number of nuclei of R present in the sample. So t is 4 minutes. We just need to remember that for now. We can get this n value out now, because over here, let's rub it off. Just remember t is 4 minutes. So again, we write it down. N by 4 n naught is equal to half into t to the power t by 1. So t was 4 minutes. We'll keep it to the power 4, which means n is equal to 4 n naught divided by 2 to the power 4. 2 to the power 4 is 16. So we have n naught by 4. That is the number remaining, right? And the same number would be remaining over there. So how much has actually converted into R? This is the remaining number. So how much has converted into R? So nR is equal to 4 n naught minus n naught by 4 plus n naught minus n naught by 4, because this is for the second species Q, where the original number was n naught, but after time t the number remaining is the same. So that is why the number that has converted into R is different. Here you have 4 n naught for this is 16 minus 1, that's going to be 15 by 4, and here you have 3 by 4 into n naught, that is equal to 18 by 4 n naught, that is 9 by 2. I think we have an option for 9 by 2 n naught. Okay, let's move on now. This says in a circuit shown below, what will be the readings of the voltmeter and the ammeter Here we see that across the inductor voltage is 300 volts. Across this also the voltage drop is 300 volts. What does that tell you? This VL and VC are equal. And we know by phasor diagram, VL and VC are in opposite directions. If the potential differences across them are equal, that means that this system is in resonance. And at resonance, the entire potential that you supply is used up by the resistor itself. So the potential you get across the resistor is going to be the full value of 220 volts. And since you also need the measurement of the ammeter, the current flowing is just the voltage divided by the resistance. So 220 by 100, so the I will be equal to 220 by 100 is going to be 2.2 amperes. So correct option is option C over here. So this question here says that starting from rest, a body slides down a 45-degree inclined plane in twice the time it takes to slide down the same distance in the absence of friction. Coefficient of friction between body and the inclined plane is. What do we know is the formula for the time taken to move a certain distance with an acceleration? The relation is T is equal to root over of 2s divided by a, where s is the distance traveled, a is the acceleration. And this is the same case over here because this is the case where the initial velocity is 0. Now, because it is at an inclined plane, the only thing that will change in this relation is this acceleration. Because if you have an inclined plane over here, then the length, the s is this length. But the acceleration, even when there is no friction, it will not be g. It will be the component of g in this direction, which is g sine theta. So in the smooth case, you would have the time Ts is equal to root over of 2s divided by g sine theta. And in the second case where you have friction, you know that this g sine theta will be reduced because in the opposite direction, you're going to have mu k into g cos theta. Because mg cos theta would be the normal reaction multiplied with mu k would give you the frictional force, divide that by mass and you get this. So Tf, the time with friction, is the same distance 2s, but here instead of g sine theta, you would be having g into sine theta minus mu k cos theta, right? So you have Ts and Tf, and the question says that this Ts is 2 times of Tf. So 2 into, let's do it here, 2 into root over of 2s by g sine theta is equal to root over of 2s by g sine theta minus mu k cos theta, right? So over here, firstly I'll square both sides, but before even I do that, I can remove the 2sg over here. So when I square both sides, I get 4 sine theta minus 4 mu k cos theta is equal to sine theta, just sine theta. I squared, so this 2 became 4, and then I cross multiplied on both sides. So that will effectively give me mu k is equal to 4 sine theta minus sine theta makes it 3 sine theta divided by 4 cos theta, that is 3 by 4 tan theta. Now theta value is provided as 45 degree, where we know tan of 45 is 1. So mu k would just be equal to 3 by 4, that is 0.75. So correct option is option C. Let's look at the next one. This says the uniform magnetic field of induction B is confined to a cylindrical region, radius r. Magnetic field is increasing at a constant rate of dB dt. An electron of charge E, there's a space missing here, placed at the point P on the periphery of the field experiences an acceleration given. So let's understand, if an electron is moving over here, that is like our coil. That is the coil. The electron's path is our coil. And we have a changing magnetic field, so there's a changing flux, so the current will be induced. Now, with regards to the force, we need the acceleration. For that, we need the force. And for the force, we need the electric field. So that is why the Faraday's law that we'll write would be with the electric field case, where we would have integration of E dot ds is equal to d into BA dt. Okay, dBA dt. BA is just the magnetic flux which we represent with phi b. Now over here the electric field is constant, let's get that out. And ds just refers to the line integral over the complete path over here, which if the radius is r is just 2 pi r. Now from here we again need to differentiate dBA dt. A is a constant, get that out. A refers to the area of the circular part, which is pi r square, into dB dt. Now over here the pi's, the pi's cancel out, one r cancels out, we'll keep it capital R, this 2 is still remaining, this 2 is still remaining, so my E is now equal to 1 by 2 dB dt. If this is the electric field, the force would be given by F is equal to, since it's an electron, it's a charge into electric field, so it would be E by 2 into, oh there's one more R over here because it was R square, there's an R remaining, so it's R by 2, E R by 2 into dB dt. Now we want the acceleration, force is mass into acceleration, so the acceleration would just be this divided by the mass, which is ER by 2m into dB dt. Okay, so we have ER by 2m into dB dt. Now in which direction will it move? Let's apply Lenz's law over here. According to Lenz's law, what is actually happening is the magnetic field is increasing. So magnetic field pointing into the page, and that is increasing, means if you have a north pole here, the north pole is coming closer. That is why the field inside is getting stronger. So if north pole is coming closer, this face should develop a north pole, which means the current should be moving in this direction over here. Current should be moving anti-clockwise, which means the electron should be moving clockwise over here. Okay, electron moves clockwise over here. Electron clockwise means with regards to point P, it moves to the left. So this is our correct option. Next one says an iron tire is to be fitted onto a wooden wheel 1 meter in diameter. The diameter of the wire is 6 millimeters smaller than that of the wheel. The tire should be heated so that its temperature increases by, and we need to find it. So how much do I want the increase in length? That is 6 millimeter. What is the original length? It's 1 meter. Diameter, radius, forget, it's just length, right? Increase in diameter 6 millimeter. So delta D, we know the relation, it's delta D is equal to D naught into alpha delta T. Now delta D is the increase in length, which is 6 millimeters, so 6 into 10 to the power minus 3. D naught is the original length, that is 1 meter. Alpha is the coefficient of linear expansion. Now linear expansion is not given, but cubical expansion coefficient is given. So the linear expansion is just the cubical coefficient divided by 3. So alpha is just gamma by 3, which is 3.6 into 10 to the power minus 5 divided by 3, because alpha is this divided by 3. And you have delta T, and that is the quantity we need to find. First up, if I remove this, I have 1.2 here. I can cancel with 6 to get 0.2 out. So my delta T would become, you have 10 to the power minus 3, that also I can take it out here, make it 10 to the power minus 2. So I have 1 divided by 0.2 into 10 to the power minus 2. So 0.2 by 1, this is going to give me 5, and 500. So our correct answer is 500 degrees Celsius. Alright, moving on, we have just few more questions left. Let's go. The radiation corresponding to from third to second transition of hydrogen atom falls on a metal surface to produce photoelectrons. These electrons are made to enter a magnetic field of 3 into 10 to the power minus 4 Tesla. The radius of the largest circular path followed by these electrons is 10 millimeter. The work function of the metal is. So there's two ways in which we need to find the work. So over here, it entered into a field and it traversed a radius over here. So from that, what do we know as the radius formula? R is equal to mv by qb. Rather, instead of q, let's keep it e, because it's an electron given over here. Okay. Yeah, these are electrons here. So EB. Now mv is the momentum, which means we can write it as root over of 2mk divided by EB, where m is the mass of the electron, k is the kinetic energy, and the kinetic energy can be further represented in its electron volt form as root over of 2m EV divided by EB over here, which means since I want to find V, my V would actually be equal to, E square B square R square divided by 2ME. That would be my V, and this V is just the energy in electron volt. Even though it might seem like potential, this is the energy in electron volt. Let's cancel out this E over here. We have V as E B square R square divided by 2M. Now we've got the energy in electron volt. Next thing, what do we need? We need it from the transition. Another way, this is one form of energy, and this we can even calculate it out actually. If I put 1.6 into 10 to the power minus 19 into magnetic field is provided 3 into 10 to the power minus 4. So 3 into 10 to the power minus 4 square. So this, let's make it 9. Let's make it 9. Let's make this 8. 10 to the power minus 8. You have R square. R is given. Where is the radius? It's 10 millimeter. So 10 to the power 1 centimeter. So squared makes it 10 to the power minus 4 divided by, you have 2m, that is 2 into 9.1 into 10 to the power minus 31. So we'll use some approximation again. That's the rule of thumb over here. So we'll cancel 9 with 9.1. We'll cancel 2 with 1.6 to give it a 0.8 here, because then I will just be having 10 up top. We have 10 to the power minus 19 into 10 to the power minus 8 is 10 to the power minus 27. 10 to the power minus 27 and minus 4 is 10 to the power minus 31. So essentially they all cancel out. You just have 0.8 electron volts as the energy. This is the energy of the photoelectrons. Now this energy is provided by the light that is given off in the 3 to 2 hydrogen transition, which means what is the energy given off there? There the energy given off is 13.6 into 1 by 4 minus 1 by 9, because 1 by 2 square minus 1 by 3 square, that is the transition from 3 to 2. So you effectively get over here 13.6 into 9 minus 4 will give you 5 divided by 9 into 4 will give you 36. So if I just cancel off some stuff here, let's take this out. This will come with 7.2. Now this 7.2 with 13.6, you can tell that 7.2 into 2 is 14.4. So it is a little less than 14.4. So I'm approximating it is around 1.9. Roughly 1.8, 1.9, roughly in that region it's going to be there. Okay. So it's going to be 1.9 electron volts. Now this is the energy given. This is the energy with which it goes out. What do we know as the photoelectric equation? We know that the photoelectric equation is the kinetic energy, which is this, which we just got, is equal to the energy supplied, which was h mu, that is this over here, energy supplied minus the work function phi, which means phi is just equal to E minus K. So 1.9 minus 0.8, it becomes 1.02, becomes roughly 1, it becomes 1.1. So we have an option, okay, see we have 1.1. Okay, others are pretty far away. So the approximations that I did hold true. If the other options were close by, then I have to be a bit more accurate, but I know that the little approximations that are made, that are no way going to take it to 1.8 or 0.8 or 1.6. They are too far away. Okay. This question here says that the figure shows a small mass connected to a string which is attached to a vertical post. If the ball is released when the string is horizontal as shown, magnitude of total acceleration of the mass as a function of the angle theta is. So over here it's coming down, and at this point there are actually two accelerations. One is the tangential acceleration at, and this tangential acceleration comes about because of the acceleration due to gravity itself. And that is because over here there's a component of gravity. If this is theta, this is 90 minus theta, which means this is 90 minus theta, which makes at as equal to g cos theta, right? This is g cos theta. Now we've got the tangential acceleration, but there is also the acceleration in this direction, which is the centripetal acceleration. And for the centripetal acceleration, we actually need the velocity, because centripetal acceleration is v square by r. We need the velocity at this point. Since it's released from this point, I know that the height it goes down by is this height, which in this triangle, if you see in this triangle, this height that it goes down by, this h is equal to L sine theta. It is L sine theta. That is the height it goes down by. And v is equal to, or rather v square is equal to 2gh, which is equal to 2gl sine theta. So the centripetal acceleration AC is v square divided by the radius. What is the radius? Radius is the length of this string itself, which is L. So v square by L. So this L cancels and you have AC is equal to 2g sine theta. So we have got AC and we saw that AT was equal to g cos theta. Now mind you, these are perpendicular. These accelerations are perpendicular to each other. So the net acceleration is just like how you would do the net acceleration, resultant of two vectors perpendicular to each other, which is A is equal to root over of AC square plus AT square. If you put that in, you will get here, this will give you, let's get the G out first off. You have 4 sine square theta plus cos square theta, right? We have an option here. Okay, we have this in this form. So here what you essentially do is that this 4 sine square theta you break up into 3 sine square theta plus sine square theta, and that extra plus sine square theta plus cos square theta makes it 1. So your final thing would be 3 sine square theta plus 1. So correct option is option D over here. Okay. Next up, it says all batteries are having EMF 10 volts and internal resistance is negligible. All resistors are in ohms. Calculate the current in the rightmost 2 ohm resistor of the circuit, which means I essentially want the main current. Now over here, see, we can simplify this, even though you might think we have to apply Kirchhoff's law where there's 3 branches, so there would be I1, I2, I3, there would be 3 variables, 3 equations, looks complicated, but we can simplify this. How do we simplify this? This 2 and this 2 are in series. So we can just ignore this. Ignore and assume there's just the equivalent 4 ohms over here. Same way, over here you see this 2 and 2, just ignore this. Think there's a continuous line and make this 4 ohms because they were in series. Also, forget about this 10 and 10. See, this 10 volt cell and this 10 volt cell are in the same direction with nothing in between. Which means ignore this, make this into 20 volts, 10 plus 10. Why am I doing that? Because now things are very simple. I'll assume that this point has a potential x. Potential value is x over there. And this point has the potential 0. If this point has a potential 0, this is a continuous line with a 10 volt cell here, which means this point has a potential of 10. Then you have x over here. If this is 10, then this point, if this is x, this point is going to be x minus 10, this point, and again this point is also going to be 10 over here. Also, another point where we can mark, if this is 0, this point is at 20 volts. This point is at 20 volts and this point is X as is. Now we have broken things down. What do we know? By Kirchhoff's junction rule. We can use Kirchhoff's junction rule now, and that is easier to deal with. Because here the current comes in. Let's assume this is I, and it breaks up into I1, I2 and I3. We know that I is equal to I1 plus I2 plus I3. Now I is equal to 20 minus X divided by 4. I is 20 minus X divided by 4. What is I1? I1 is X minus 10 divided by 4. X minus 10 divided by 4. Next up, what do we have? We have this I2. I2 is X minus 10 minus 0. X minus 10 minus 0 divided by 2. So you have X minus 10 divided by 2 plus I3, this path is X minus 10 divided by 2 again. 10 divided by 2. And I think we have taken care of all of the points. Fine. So that takes care of all the points. Let's multiply across the board with 4, because if you multiply with 4, your equation becomes simpler. It becomes 20 minus X equal to X minus 10 plus 2X minus 20, because when I multiply with 4, this 2 cancels only 1 2 in that 4, plus 2X minus 20. Now over here we need to simplify and get this X. So let's see. You have, bring the X this side, you have X plus X 2X, 4X, 6X. So 6X is equal to, bring all the numbers this side, 20 plus 10 30 plus 20 50 plus 20 70. 70. So X is equal to 70 by 6. Okay. Did we do the calculation right here? You have X plus X 2X, 4X, 6X. There you have 20, 30, 50, 70. Yeah, X is 70 by 6. Now I want this main current I, and I was equal to, I we saw was equal to 20 minus X divided by 4. So if we do 20 minus X, that is 70 by 6 divided by 4, that is equal to 120 minus 70 makes it 50 divided by 4 into 6. So 50 by 24, that should be roughly equal to, okay, we can cut it even further, making it 25 and 12, because we have an option matching that. It is 25 by 12 amperes. So this is a lot simpler than dealing with the Kirchhoff's law method, where we are also using Kirchhoff's law here, but I am talking about dealing with it with the Kirchhoff's voltage rule, because there you have 3 equations, solve, replace one variable from this to that, becomes very complicated. Okay, let's move on. This one says a sphere rolls down an inclined plane without slipping. What fraction of its total energy is rotational? So we know that the energy, the kinetic energy, is the linear kinetic or the translational kinetic energy half mv square plus the rotational kinetic energy half I omega square. Now this can be written as half mv square plus half of, since it's a sphere rolling, the moment of inertia is about its center, and that is given by 2 by 5 m r square, where r is the radius of the sphere, multiplied with omega. Now since there is no slipping, omega is equal to v by r. Okay, if there was slipping it would be different, but right now its omega is v by r. So we have v square by r square. Cancel out the r squares. You have this as half mv square into 1 plus 2 by 5, that is 7 by 5, right? This is the total energy. What do I need? I need the fraction of its total energy is rotational. What is the rotational energy? Rotational energy is just that, it's half I omega square. Half I omega square, which we saw was equal to half into 2 by 5 mv square. So ER by E, the fraction is just half mv square into 2 by 5 divided by half mv square into 2 by 7. If you do, you will get this as into 7 by 5. If you get the 5's will cancel, half mv squares will cancel, you will just have 2 by 7 remaining. So correct answer is option A, 2 by 7. Okay. This question says that two identical piano wires kept under the same tension T have a fundamental frequency 600 Hz. The fractional change in the tension of one of the strings which lead to occurrence of 6 beats per second when both wires oscillate together. So this just tells you that changing the tension actually changes your frequency by 6 Hz, because that is why the beats have formed. We know the relation for frequency. It's a piano string, means it's a string clamped at both ends. It's 1 by 2L root over of T by mu. If I write this in its error form, you can even look for the error form by doing the logarithms and then differentiating and so on. But we will essentially get that df by f will be equal to half of dt by t. T refers to the tension over here. Why do I have this factor of half? Because the power of T was half. Okay, that is why I could use this approximation here. Now df by f, this is the simple error formula. Now df by f is already given to us. Okay, we want the fractional increase. So dt by t is what we want. df by f is given to us because df is 6. So let's do this. dt by t, that is what we want, is 2 into cross multiplied df by f. df is 6 divided by f. F is the original frequency, which is 600. You have 100. So 2 by 100 makes it 0.02. So that is a fractional increase. If you try to put the values, calculate for each case, in the second case put 606 Hz, try to find tension, long procedure, you will make a mistake there, because especially because you'll have to deal with squares and roots in that case. Okay, so as long as this percentage is less, you can use this error relation. When the percentage is more, so like 6 beats with regards to 600, it's very less, it's 1 by 100. But if you see that it is doubled from 600, it is made maybe even 900, it has increased half times, 50%. Then you can't use this approximation. Then you'd have to separately find tension for each cases and then get the relative change in tension. Okay. Oh, that's it. We've finished all the questions for this session. Now you'll be getting more such questions as part of the series coming up. So subscribe to the channel for that. Also our courses, if you're in your class 11 and you're watching this, then we have our courses live on Infinity Learn. We have classes for students who have just got into class 12 and also for students who've got into class 11. If you want, you can use my coupon code here. The coupon code during the checkout would be my name, Aniruddha 20, and you would get a 20% off in any purchase that you do on Infinity Learn. Besides that, you'll also have the link to the Telegram channel. So go check that out. We post content, slides and everything over there along with updates. So follow us over there. Thank you so much for watching. Catch you all in the next one.